We'll cover the respiratory system today, and we'll begin with a few functions of the respiratory system. The main one is gas exchange. Exchange of oxygen and carbon dioxide. We have gas conditioning. The respiratory system warms and it humidifies the air that we breathe. Sound, of course, comes from the respiratory system, the vocal cords. We have olfaction occurring in the respiratory system within the nasal cavity. And then we have defense. Okay, the respiratory system is designed so to prevent foreign invaders from entering and getting in our body. The respiratory system can be divided into two parts. There's an upper respiratory tract and a lower respiratory tract. The upper respiratory tract includes the nose and the pharynx. Now remember, pharynx, it's inx, Y and X, not NYX. It's not pharynx, it's pharynx. That's a common mistake that people make when they pronounce it and actually spell it. So pharynx, Y and X. The lower respiratory tract includes the larynx, or the voice box, the trachea, the bronchial tree. Once the trachea extends down, it divides into the bronchi, and the primary bronchi, secondary bronchi, tertiary, and it continues to branch and branch till you get to the bronchioles, and then to eventually end in the alveoli. The respiratory alveoli are those grape-like structures across which gas exchange occurs. And then, of course, we have the lungs, which are part of the lower respiratory tract. One thing to remember, kind of almost throughout the whole respiratory system, we have what's called the respiratory epithelium, or mucous membrane, sometimes called. This is made up of pseudostratified, ciliated columnar epithelium. Okay, so the respiratory epithelium is pseudostratified, ciliated columnar epithelium. Now there's some areas where this is not the case. The pharynx, which is the throat, the oropharynx and the laryngopharynx, those areas, because of they share, they're shared by the digestive system. So those areas are going to encounter a lot of friction, right? As you swallow food, so that epithelium will have to be a little different. It's non-keratinized, stratified squamous epithelium. So you have a lot of thin, flat cells stacked on top of each other, but they're not keratinized, meaning they're not in the skin. The upper part of the larynx also is non-keratinized, stratified squamous epithelium. All right, but then as you get farther down, it maintains that respiratory epithelium until you get down into the lower parts of the bronchial tree. Those little bronchi might have either cuboidal cells. The cell type will change. It might be cuboidal or maybe even columnar. And then, of course, when you get to the alveoli, the epithelium changes again because it's where gas exchange occurs, and so we want it flat, and it's actually a simple squamous epithelium, which is one cell layer of flat cells, which allow for the proper amount of gas exchange. Let's see. Next, let's take a closer look at the alveoli, where actual gas exchange occurs. So, if we look at you'll want to go to your book for a proper picture. The alveoli, again, are lined by simple squamous epithelium, so allows for gas exchange. there's a great network of capillaries around the alveoli, which you would expect because, you know, you have to exchange gases with the blood. And so it's really made for that purpose. There's about 300 to 400 million alveoli per lung, so there's a lot. Remember, the alveoli are little grape-like structures like that. Maybe I'll draw a bigger picture. All right, and again, this layer is simple squamous epithelium. Now, the walls of this are made up of 3 parts. So 3 types of cells. That comprise the alveoli. The first one are the squamous cells, the simple squamous, and that they're called alveolar type 1. Type 1 cells. So I'll just say simple squamous. And again, this is for gas exchange, occurs there. So but they're called alveolar type 1 cells. The other type is alveolar type 2 cells, or septal cells. Okay. These cells are cuboidal cells. But they're important because they secrete what's called a fluid called pulmonary surfactant on the inner lining of the alveolus. So I'm going to put secrete pulmonary surfactant, which is a fluid. Okay, on inner surface. Now, why is that important? The interesting thing about the inner part of the alveoli is there's water molecules in there, and from your chemistry, there's a very strong, pretty strong bond between the water molecules, hydrogen bonds that hold them together. And we know that bond is very strong because, little bugs can walk on water, and when you put a drop of water on a table, it almost appears like it has a skin. That's the reason why you can fill a glass higher than the rim, because it has this surface tension, this tension created by these bonds between the water molecules. And so because the layer is so thin here, you have this layer of water here lining that's kind of pulling. The bonds are really tight, and it's pulling those molecules together and holding it together. And if you don't have this surfactant, the alveoli collapses because of these bonds between the water molecules and this very high surface tension on the inside. So surfactant, this fluid produced, decreases the surface tension. So it decreases surface tension on inner surface. Preventing collapse. Okay, so it makes this, and it prevents it from collapsing in because of high surface tension without it. The third type of cell found within the alveoli are called alveolar macrophages. Sometimes called dust cells. And these, they're just immune cells that engulf microorganisms or debris. All right. The last thing I want to briefly discuss is breathing and the muscles that are involved in ventilation. So I'm going to do that really quickly. So breathing, we have inspiring or inspiration when we inhale and expiration for exhaling. Some important muscles so for inspiration or inhalation, we have, of course, the diaphragm. The diaphragm is the main inspiratory muscle. And we have the external intercostals. The intercostals are the muscles found between the ribs. You know, when you eat ribs and barbecue them, you're eating intercostal muscles between the ribs. So the external ones and the diaphragm, when you inhale, these muscles contract and the diaphragm lowers. The external intercostals cause your chest cavity to expand, and what you're doing is you're creating a bigger volume. You're making your chest cavity bigger, which decreases the pressure, so the pressure lowers, and that causes you to suck air into your lungs. Exhalation is a passive process. All you do is you relax your inspiratory muscles, and by relaxing them, the diaphragm and the external intercostals go back to where they normally are, and increases the pressure, decreases the volume in the thoracic cavity, cause you to expel air. Now, when you want to do extra work or talk or sing, you have to contract your internal intercostals and abdominal muscles. So I'm going to put forced exhalation or expiration is the abdominal muscles. And the internal intercostals. And so that gives you an added amount of push, decreasing the thoracic cavity even more and allowing you to get extra air out. Alrighty, see you next time.